Design your own life. With Lesmana.
Subscribe, tekan tombol bel, share dan like videonya ya guys. Terima kasih.
Well, it's all about cycles of time. Scientists now recognize that we are living the rare convergence of three massive cycles of change. Cycles of climate, economic cycles, and cycles of human conflict. And I want you to know these are natural cycles, and they follow natural rhythms that we can know, we can predict, and we can calculate. And they appear on a regular basis. And that's what makes today so different. All three of these cycles are appearing at the same time. They're colliding right now, and it's happening in our lifetime. The primary source of information about the history of our planet comes from the seafloor sediments and the core samples that scientists pull up out of the oceans. It comes from the ancient tree ring data. The problem is the tree rings only go back a couple of thousand years. And it comes from the ice cores that we find in the ice sheets of Antarctica and Greenland. So I'd like to zero in on those ice cores a little bit. From the ice cores, tremendous amounts of information can be detailed by scientists who know how to read these ice cores like we read the pages of a book. Each year, when that new layer of ice is deposited, that layer captures the information, whatever was happening in the atmosphere. If there was a volcanic eruption, we've got volcanic dust particles. If the wind has blown pollen grains into Antarctica from Europe, then we know that. In the ice cores, we can tell how strong the magnetic fields have been in the past, how strong the sun is, tremendous amount of information, how high the sea levels were. Here's the key, we can tell what the ancient temperatures were as well. What we're seeing now is the information going back over 420,000 years into the history of the Earth. 1999, scientists, international scientists, recognized that global warming was actually melting the ice and destroying this library, this record that we have in Antarctica. And they said, even though we don't know why the warming is happening, let's drill through the thickest part of the ice and we'll capture as much data as we can. Then we can go back and figure out what's causing the warming. Well, even the scientists were absolutely amazed because when they pulled that ice core up from an area that is called Vostok Lake, in the very famous Vostok ice core, they pulled up over 420,000 layers of ice. Each layer represents 1 year of the Earth's history. So all of a sudden, we've got 420,000 years of our past to compare to today, to see if something's wrong, to see if Earth is broken, to see if there's something truly anomalous happening right now. You're seeing two different ice cores. In blue is the EPICA ice core from another location in Antarctica, and the green is the Vostok ice core. And what I'd like to call your attention to, just right off, even if you know nothing about how to read this information, you can see the cycles, you can see the rhythms. And it's not your imagination. There are nested cycles, cycles within cycles. There are 100,000-year cycles, there are 41,000-year cycles, there are 26,000-year cycles. There are even 5,000-year-long cycles. So the way that we can read this graph, the 420,000 years begins on the right-hand side of the screen. We're present day on the left at year 0. And if you look at either the blue or the green ice cores, what you can see is they tend to agree with one another. There are times when the temperatures of the Earth have ebbed and flowed, when it's been warmer and when it's been cooler, and when it happens in one place, it happens in another place as well. The red that you're seeing at the bottom of the graph is the thickness of the ice as it correlates to those temperatures. So what is obvious when we look at this graph is that if you look at year 0 today, we are a little bit above the average temperature for where you would expect Earth to be. I would expect to see some global warming right now. I'd be concerned if we didn't, because that is what has happened in the past. The question is, how much warming is normal? How much warming should we really be seeing? Well, the next graph that I'd like for you to see is a graph that also comes from the ice core data and the seafloor sediment data. However, it does not contain the tree ring data. And it's telling us something really, really interesting. This graph begins at year 0 and goes for 2,000 years into the year 2000. The green line that you're seeing in the middle of this chart is the average temperature for the Earth over these 2,000 years. And the chart, the graph, is showing us above and below that average where we have seen the temperatures in the past. So it's obvious. Sometimes the temperatures are above normal, sometimes they're below normal. Here's why this is so interesting. If you look closely, where we are today, are we above normal? Absolutely. We're above the average normal for where Earth has been in the past. Are we warmer now than we have ever been? Absolutely not. Look at this. If you go back into the years 12 to 1300 in what is called Common Era, CE, they're using this notation now instead of AD and BC to remove any religious implications. So when I say CE, it means Common Era from the year 0 to now. 12 to 1300 Common Era, the temperatures were almost twice as warm as they are right now, twice the anomaly that we're seeing right now. And if you go back into the years 820 to 1040 Common Era, look at this, 3 times above where the anomaly is right now. And scientists know this because they have a name they give to this period. It's called MWP. It means the medieval warming period. So the point of me sharing this with you is to show that the warming does happen, and I would expect that we would be in a warming cycle now, and that the warming is not the warmest it's ever been. And if you look closely, the warming, when it happens, it's brief, it's intense, and it's what comes right after the warming that sometimes can be the problem. It's the cooling that follows. This is a very, very powerful graph, and I'm going to walk through it slowly so you can see exactly what Mother Earth is telling us. And that is the value of looking at the information from the Earth herself. We're not seeing this interpreted through the eyes of a corporation or of a political or religious agenda. This is the Earth telling us her story. And the story is fascinating. In this particular graph, the year 0 to the right-hand side of the screen, that's us, that's where we are today. I'm going to go back to the 420,000 years from where the ice cores were in the previous graphs. And if you'll notice, you're looking at 2 colors, red and blue. The red are the temperatures of the Earth, the average temperatures, and the blue are the levels of greenhouse gases, particularly carbon dioxide. And I'm showing this because we're being told that it is the carbon dioxide in the greenhouse gases that is causing the temperatures of the Earth to rise and causing the concern. The data in this graph doesn't support that theory. And I want you to see precisely how this works. So if you follow with me, if we're moving from that 400,000 years toward the present, so we're moving from the left to the right-hand side of the graph, what you see is that the red lines rise before the blue. That means the temperature is rising before the greenhouse gases. And this is what's recorded in the ice cores in Antarctica and in Greenland. The temperatures rise first, and then the greenhouse gases, the carbon dioxide, follow. And there is a lag time. They said when we are going from what's called an interglacial condition, and that's where we are right now. We're not in the glaciers, we're in between the time when the glaciers appear. So when we're going from interglacial into a glacial condition, into a time when the Earth cools, the change in the carbon dioxide actually lags the change in the air temperature. It lags, and that lag time is usually 4, 5, 6, 7, maybe 800 years. So there's that lag time. So this is from peer-reviewed science in the journal Nature.
Here's an example of a core that goes back some 100 to 200,000 years. And the sediments within this show clear differences visually, which have been caused by differences in climate. Now you can see here a whiter carbonate ooze and here a red-brown clay. These carbonate oozes have been laid down during interglacial periods, warmer periods, and these red clays have been laid down during the glacial periods, cooler periods.
Now I want to go back and take a closer look at this chart because it's telling us even something more profound. If you look closely, when the carbon dioxide levels do increase, when they go up, the temperatures actually drop. the stronger the carbon dioxide levels, the cooler the temperatures on the Earth become. Now, why is that important? Because it is a fact. We have thrown tremendous amounts of carbon dioxide into the atmosphere. We have now created more of a carbon dioxide burden in the Earth's atmosphere than we have in the 420,000 years that we have the history for. We've never seen. Higher levels of CO2 have created a cooling effect. So the question that obviously comes up is, if the carbon dioxide is not causing the changes in the climate, as we have been led to believe, as many scientists believe right now, then what is? So this is the key. If you go to the Inuit elders in the Arctic regions and you ask them what it is that's causing this change, they will tell you. They will tell you that the Earth has changed her location in space. They'll say that their sky has changed. This is the term they use, their sky has changed. Well, there was an Australian astronomer, his name was Milutin Milankovic, who agrees with this. Before he died in 1958, Milutin Milankovic had created a theory. Milutin Milankovic recognized three big cycles, shifts in the location of Earth in space. One of those is called the precession of the equinox. Precessions are about 26,000 years long, and our ancestors knew that. So that is one of the cycles. A second cycle is what is called eccentricity. And what that means is that as Earth moves around the sun, it's not a circular orbit, it is an elliptical orbit. Sometimes in the ellipse we're closer to the sun, sometimes we're further away. That means the cycle varies. When we're close, about 41,000 years. When we're further apart, about 100,000 years. That's the second cycle. And the third is called the tilt, or the obliquity. Okay, so these three cycles that Earth is going through as it moves around the sun, now you know what they are. Let's take a look at them as they are plotted on a graph. And you're going to see something absolutely astounding. So what you're seeing in the graph on your screen right now, the red is the precession of the equinoxes, the green is the obliquity, and the blue is the eccentricity. Now, if you look closely as they ebb and flow, if either eccentricity or obliquity or precession, if any two of these rise at the same time, look at what happens. The bottom of the screen, you're seeing warming and cooling of the Earth. And you can see that when eccentricity, for example, and obliquity, when those coincide, we have a warming period on the Earth. And I'm showing you this on the screen right now, and you say, well, maybe that's an anomaly. Maybe it's just that one time. But look at this. If we go back and look at each of these, here we're seeing eccentricity as a peak, and we're also seeing obliquity as a peak in the blue and the green, and right below that, every place where that happened, we saw warming in our planet, and it happens all the time. So the reason this is important is because we are here at the far left of the screen, where that red line is, that's us. And we're having a little bump in eccentricity. We're seeing that coincide with the obliquity. So we're seeing this dance that Earth is doing in a very precise way that has created warming in the past, and it's doing the same thing right now. So this is one of the cycles, climate. And I mentioned there are three cycles that are converging. The second cycle that I'd like to talk to you about is the cycle of economies.